All right, so for this next video, we're going to consider algebra before solving a trig equation. So I've got a trig equation here that says solve sine squared x minus 1/2 equals 0. Well, if I want to solve a trigonometric equation, I need to get it to one of those places where I can use either special triangles or an inverse trig function, which means I need a sine of something on the left and a value of the ratio on the right. And then I just need to check to see whether those are equivalent or not. So my first step is going to be to take this negative 1/2 and move it over to the other side. Then I'm going to deal with this square. So let's take a look at how that works out. So when I move that over, it becomes positive 1/2, and I have sine of x squared is equal to positive 1/2. Now, how do I deal with the square? You'll have to remember that sine squared x is really sine x to the power 2. Now, I don't have to write this step, but I'm just showing you that this notation and this notation are equivalent. This notation's better, but these two things are equivalent. So we're going to get rid of this square by taking the square root. So we'll have sine of x is equal to 1 over root 2. But wait, when you take the square root of something, 1 over root 2 times 1 over root 2 is 1 over 2. What about negative 1 over root 2 times negative 1 over root 2? Well, that makes also 1 over 2. So we end up having both the positive and negative from dealing with that square, taking the square root. This leads to two possible equations. So we have sine x equals 1 over root 2, or we have sine x equals negative 1 over root 2. So that plus or minus led to two possible solutions here. Now, if you know your unit circle, you know that the sine of x equaling 1 over root 2 is going to be pi by 4. If you don't know your unit circle very well, just go ahead and draw a sine of 1 over root 2. Well, that's positive, so it's in the first quadrant, and a 1 and a root 2 belong in my 1, 1, root 2 triangle. That's the 1, 1, root 2 triangle right here. And so that means that that angle right there is going to be equivalent to pi by 4. Now, wait a second. There's another place, because it's also 1, 1, root 2 in the second quadrant, because remember, sine is positive up here and here. So from this, we have two solutions. And then from this, we have another two solutions, but they're in the places where it's negative 1 over root 2. And down here, negative 1 over root 2. So this was pi by 4. This is 3 pi by 4. 1 pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4, 8 bottle of pop, 9 bottle of pop, 10 bottle of pop, 11 bottle of pop, fish and chips and vinegar. I'm not going to do that, sorry. So 5 pi by 4 is one solution, and 7 pi by 4 is the other solution from there. Now, I should recommend that this is good enough for IB in most cases. So IB tends to always give you an interval like I talked about in a previous video. However, I don't always give you an interval. I don't like the fact that we're only looking for 4 solutions. I want all of the solutions. Now let me just list these solutions in order. Pi by 4, 3 pi by 4, 5 pi by 4, and 7 pi by 4. Seems like each time they go up by 2 pi by 4. That's right, from here to here is pi by 2. It makes a right angle. And from here to here is pi by 2. It makes a right angle. And from here to here, pi by 2. It makes a right angle. So actually, this is an arithmetic sequence. And my solutions are x equals pi by 4 plus some value of pi by 2. So pi by 4 plus 1 pi by 2 gets me to there. Pi by 4 plus 3 pi by 2s gets me to there. Pi by 4 plus 4 pi by 2s gets me back to pi by 4. This describes all of the pi by 2s. Sorry, all of the solutions. Not just in the positive direction going around here, but also in the negative, because there's a solution back here at negative pi by 4 as well. Well, pi by 2 minus 1 pi by 2, pi by 4 minus 1 pi by 2 is negative pi by 4. So that means this n has to carry positive and negative values. but it only has to carry whole values, because if I use a half for n, then that would put me right here, which would not be a solution. So I create what's called a parameter in my solutions. I've got pi by 4 plus n pi by 2, where n is an element of the integers. And that is finding all the solutions to a little bit more challenging of a trig equation. Again, like I said, most of them are going to give you an interval. So if you see something like on 0 to 2 pi, then this last part here is unnecessary, and you only need to go to here and here as your solutions. But if you don't see this, then that's telling you, hey, I want all of the solutions. Cool, I hope that helped clear things up.